right, so homework-wise, the rule was that as long as you had a square to a square, they were the same sizes, you could add. And then all you had to do was add the equivalent or subtract the equivalent. So like this one would have been 10, 10, 10. And then 10, 5 and 5's 10, 6 and 4's 10, 7 3's 10, 8 2's 10. And added together, that's all it ends up. Okay? And the same when you're subtracting. So 5 minus 1 gives me 4. 4 minus negative 2 is going to give me 6. 3 minus 3 is 0. 4 minus 4 is 0. 0 minus negative 5 is a positive 5. 4 minus 6 is negative 2. 7 minus negative 7 is going to be 14. 10 minus 8 gives me 2. And 3 minus 10 gives me 7. Yeah. Need to... Don't look at me. Okay? Are we good on those? Easy peasy? All right. Then, when we were doing multiplication, it was like putting a 5 out in front of the 0, 4, minus 2, 1, 4, 1, and then distributing to each spot. And 3 would be the same. And then after you got that answer, you subtracted the b. Are you guys good on how to do all these? Okay. It's super easy in your head, right? Yeah. It's really easy. However, if you are going to have to do like a lot of problems where you have the same set of matrix, like I could put in 3 and then do my alpha zoom and say, hey, I want a 2 by 3, and then fill that matrix in to get the answer, okay? And that works. But if you're going to do like a lot of different calculations, like you have these down here, and actually I'm going to call this A and that one B just to make it easier in my calculator. Program the actual matrices in. Go to your matrix place, okay? And right now I have A, B, C, and D stored. A is a 2 by 2, B is a 2 by 2, C is a 2 by 1. All right? So I'm going to edit the very first one. Actually, you know what? We're using G and F. That was G and F, right? Let's just go down and put in G and F. All right, so I have G. It is a 1, 2, 3 by 2. And now I can enter it. So 1, 2, 3, 4, 6, and 7. Everybody with me? Okay, so now when I go back to my matrix, it's now stored. All right, so then let's put in F. So my F is a 3 by 2. Oops, that's not what I want. Matrix, edit, F. And I want it to be a 3. Whoa, not 33. 3 by 2. 1, 0, 1, 1, 0, 1. All right, because now that it's stored, if you have a lot of operations, you don't want to have to repeat doing it. I can do, hey, -2 times my matrix G And there's the answer. Okay? And then I can say, okay, now I want to do 5 times my matrix F, and then I want to subtract, oops. I want to subtract G. You with me? All right, I'll come help you here in a minute. And then it'll just give you the answer, okay? So if you're doing one problem with the matrix, then it's easier to do your alpha zoom and just pull up the matrix. If you're using, like tonight's homework, which is going to have 5 different matrices, but you use them the same matrices, take the time. It's easier then to take the time and just go ahead and load them, because then you can just plug and chug. Good? Make sense? And Nicole, I'll help you here in a minute once we get through with the notes. We're going to do we're going to do back and forth notes today. We're going to start on one page, and then we're going to do an example on the other page, then come back. Okay, so this is the page we're going to start with. That's the second page that we're going to go to. Oh, to get back to behind you. That's why. All right, so let's start with this page. Okay. And today is the 4th. I guess it is kind of rainy and cloudy. Would you please pass back? All right. So, when we were doing the addition and subtraction yesterday, we just literally matched position to position. Element in 1-1 went with element 1-1 in the other one, right? Same kind of thing this time for multiplication. It's a little more complicated, but we're going to use, like, for the position, the row and column that matches. So you use the entire row and the entire column. Sir?
I did not get that paper.
This one?
That one is an extra one.
Okay. Yep. All right. So, the true definition of the product says that an m by n matrix and B, another m by n matrix, is the product is the m by n matrix C, where the entry in row I, column J, is the product of the ith row of A and the j column of B. That's the math speak of it, okay? Row for A, column for B, add together. That's what it's basically saying, okay? So you're going to use the row of the first times the column of the second. And I'm going to show you an example here, okay? But there's one catch. The number of the columns of A has to be equal to the rows of B, because that's what you're matching up. So if they don't, then the product's undefined. All right? So if you have a 2 by 3 matrix, can we multiply it with the 3 by 4? So it's row, column, right? And row, column. Think of it this way. If you have the two inside, they have to be the same. If they match and they're the same, then you can multiply it. And if you do, if it can be multiplied, the two outside is the size of the resulting matrix. So a 2 by 3 multiplied by a 3 by 4 is going to give you a 2 by 4 matrix answer. Okay? All right, so let's look at that. We're looking at matrices A and B here and whether we can multiply it. So A is a 2 by 3. B is a 3 by 2. Can we multiply them together?
No. Yes.
I've got no's and yeses.
Yes, yes.
These two are the same, so yes, we can. All right. What's the size going to be of the result? The 2 by 2. Okay, does that make sense? All right. So let's go to this other piece of paper now.
Okay.
Because we're going to actually do the multiplication. All right? And the multiplication, it's not hard. It's just kind of confusing for a second. So we have A times B, and A is a 2 by 3, and B is a 3 by 2. So the first question, can we multiply?
Yes.
Yep. And what's the result going to be?
2.
A 2 by 2. So that's why I have a 2 by 2 there. Okay, because that's what our answer is going to be. Now, remember when we were talking about the product back here on the thing? It was basically the row of the first and the column of the second. Okay? And so what that is saying is for this position here, it would be considered A11, right? Because it's first row, first column, right? Okay, so what you do is you multiply row 1 by column 1. And we're going to add them all together, and that becomes our answer for that position. Okay? So, row 1, I have 6 times column 1 times 1. And then I have -2 times 5. With me so far? Then I have 8. Oops. Oh, wait a minute. 2 times. I forgot my 5. I have 8 times 2. So 6 times 1 is 6. -2 times 5 is -10. 8 times 2 is 16. And so when I add all those up, I get -4 plus 16. So the results for that one is going to be 12. Does that make sense? All right, this position is a 21, right? Because it's row 2, column 1. So that means I'm going to multiply row 2 times column 1. So I have 1 times 1 plus 4 times 5 plus 5 times 2. Does this make sense? And so I have 1 plus 20 plus 10, and so that position's 31. Like I said, this isn't hard. It's just kind of time consuming to have to sit and do these. So this one is position A, row 1, column 2. So row 1, 6 times 3 plus negative 2 times 0 plus 8 times 7. Are you with me, Nicole? Awesome. 18 plus 0 plus 56 gives me 74. All right, and then my last one, 2, 3, is position A22. So I'm going to use row 2 times column 2. So I have 1 times 3 plus 4 times 0 plus 5 times 7 so 3 plus 0 plus 35 gives me 38. So multiplying A and B, my final resulting product would be 12, 31, 74, and 38. Easy peasy?
Not really. It's not a faster way of doing this.
In the calculator. But faster way by hand? No. Okay. Does it make sense? I'm not saying it's not time consuming. But matching up the two. Yes? All right. Shall we do another one? Or would you want to do it in the calculator? Yes, no. Okay, well, first of all, A is a 3 by 2. Agreed? B is a 2 by 3. What are we left with? Or, I mean, can I multiply them?
Yes.
Yeah, because 2 by 2. We're good. And my result is a 3 by 3. So I would have to do... Oh, my bad, sorry. So I would end up having to do 9 calculations of the rows. That makes sense? That's going to take me forever, so let's do calculating.
More because it'd be a 2 by 4, so it'd be a 3 by 4.
Oh, it is a by 4. Oh my goodness gracious.
I said Miss Myra, it's a 2 by 4, and you said sorry.
I thought you meant because I moved, you couldn't see it. I'm sorry. And then I was thinking, oh yeah, oh boy. So it's a 3 by 4.
Sorry.
Sorry.
It's one of those days. That's going to take forever. Let's plug and chug in the calculator. Okay? Now, so that means, thank goodness.
I'm just saying.
Lazy butt. All right, so the first one is a 3 by 2. Okay, and I have 1, -2, 3, 1, 0, and -1. And I am multiplying it by a 2 by 4. Okay, and that one is 2, 5, 3, 0, 4, -1, 2, and 1. And boom, there's my answer. Is that the shortcut you were looking for? Yeah. The larger ones like that definitely are going to take some time. Now, if I have, what if I wanted to find B times A? Can I do that one?
No,
Why?
because they're not the same answer.
Yeah, I have a 2 by 4 and a 3 by 2. Not the same, so I can't do it. What if you forgot that rule and you plugged it into your calculator? What would it look like? Well, let's try it. So if I have, this time I want a 4 by 2. And so I guess it really honestly doesn't matter what numbers I put in. And I'm multiplying it by a
2 by
3 by 2. Come on. 3 by 2. Right? And then let's just put in 1, -4, 5, 8, 7, 8. Dimension mismatch. Okay? Meaning the dimensions of your matrices don't match and you can't do it. So even if you forget that rule, the calculator will tell you as well. Okay? Cool? Make sense? All right, we have 15 minutes left. Calculator practice for the first one. And then you have 5 different matrices. And you have, what is it, like 8 problems. I personally would take the time to load them in my calculator, the first, just so I could plug and chug. But you don't have to. However, 1 through 4 is no calculator. All right? Please do it. Because, look, it's A plus B. 2 plus 4, -4 plus -1, 1 plus 2, 3. You could do those in the head. And even when you're having to multiply, you're going to do the rows like we did here. But they're very small. So you're only going to end up having to do, because you're going to get a 1 by 2, so you're only going to have to do like 2 calculations. All right, good. Questions, comments, cares, concerns?